evening, students. Good evening, student. I think my voice is. Good evening, students. I think my voice is clear to you, everyone.
Yes, sir.
Okay, and
Yes, sir.
video is also clear to you.
Yes, sir.
Okay, good. So today we will start a special theory of relativity, but today we will just discuss the introduction of a special theory of relativity. That we will just go one step behind that. We will just try to introduce the inertial frame and what is Galilean transformation and why we need a different type of transformation that is very popularly known as Lorentz transformation. And from the Lorentz transformation, we will go into a special theory of relativity. So first, I will discuss what is your course structure and where we have to focus the thing. Today is just a first class, so relax yourself. Today just we will discuss different type of definition only, because it is very important to apply on a problem. If you don't know particular definition or concept properly, then it will be very difficult to apply on a problem or in different application purpose. So it's a very interesting topic, and it's a very important topic also. So let's first go to all what is your syllabus and what is your approach towards this particular topic. So today we will just go for basic definition. Basic definition. It is very important, but most of thing I am sure that you people know, but it's my duty that I have to revise from scratch. But next class we will just go into Lorentz transformation. And if we will learn Lorentz transformation, then we will learn the relative speed. And these two things are very much correlated to each other. And these are basic core of the subject. Once we learn these two things, and then we will apply this particular Lorentz transformation and relative speed on different application, and we will try to see different type of phenomena. So first phenomena we are going to discuss is all about length contraction. Second phenomena we are going to discuss is time dilation. And third is we are going to discuss loss of simultaneity. Loss of simultaneity. So these are very important thing. We should involve the kinematics into the calculation. But when we are talking about relativistic dynamics and a special theory of relativity, then relativistic mass is most important concept, which will complete all this structure. So next we will go for relativistic mass. Relativistic mass. Once we learn relativistic mass, then obviously we will just go for relativistic momentum. Obviously, we will just go for relativistic energy. And also we will just go for conservation of energy. of energy and momentum. And then we will go for a very important topic. Just we will try to generalize each and everything in form of symmetry. We will try to learn a very new type of symmetry, and that can be discussed by four vectors. And then we will also learn little bit of Minkowski space and all kind of thing. So these are the part of special theory of relativity. The extension of this topic in advanced part, mainly for net student, gate student, are of relativistic electrodynamics. And finally, we will go for relativistic quantum mechanics. This is advanced topic. So this is typically advanced. So if you are preparing for JAM, then you can skip this topic. Or if you are able to digest each and everything, then you can go into this topic, because we will take this topic when we will go into electromagnetic theory, and we will take this topic when we will go into quantum mechanics. But these are the basic things. So we can divide all the thing mainly three parts. So first part is all about this one. The concept is exactly same. The formulation is exactly same. So this is broadly first part. So I have included all this thing into chapter 1, which will be given into your study material. You can just check into your Google Classroom. And this part will be just covered into second part, and we have given this thing into chapter 2, this B part, and this C part. And obviously here we will also discuss Doppler's effect. We will discuss Doppler effect with help of four vector. So this is the symmetry will be your C part. So these three chapter we will try to cover into next 10 day. So next 10 days is enough for this one. And we will try to build a wonderful concept such that we can solve each and every problem with a same methodology. So this is our main challenge, that we should see the problem and we just apply with the basic concept, with the help of basic concept, and we should go for a step by step calculation. Okay. And I will just tell you, just focus on my class. Okay. First focus on my class. Then obviously tutorial sheet will be always with you. So I will just give you one question and two question as homework for every day. Today we have just introduction class. So today you are a little bit of relaxed on this sense. And obviously you should apply your brain onto previous year questions. So these three things we will cover first. And once you have enough time, then you can go for worksheet and all other thing. The best book, I can say there are a lot of books for this particular special theory of relativity. For the basic level, the Arthur Bazer modern physics book is very nice. But I modern physics Arthur Bazer, and one very nice book is that is only for the special theory of relativity, written by Resnick. So that is very thin book, but very nice book. But I will suggest you just follow my lecture and just go and solve the problem. If you needed any help, then you can ask me. I will provide substantial uh, written material or substantial notes. Whatever the study material given to you is fully covered by my lectures. So you can just revise from that. So you can just see each and every part from next two classes, after next two class. So this is the way we will just try to learn this particular topic, a special theory of relativity. If you have any query right now, you can just let me know. Everything is okay? Then we should start our introduction part. We will just go for basic theory of inertial frame, and we will little bit discuss all about Galilean transformation. It's okay? Okay. So okay. So let me start with a very simple question. Suppose I am saying that I am on the frame A, or I am on the reference, I am on rest on the reference frame A, or I am rest on the reference from of any platform. So what is frame actually? So first thing, we will just try to learn what is frame. So obviously, if I am saying that I am watching the another train from the frame of platform, means I am rest on the platform, I am attached to the platform, and I am watching the moving train, or it may be train, may be static, it may be different story. But if I am talking about frame, in general, I am talking about one coordinate axis. I am just talking about one coordinate axis. One coordinate axis means I am just talking about these coordinate axis is not a spherical, polar, or cylindrical coordinate. Just one Cartesian coordinate is attached to one particular frame. Suppose I am talking about, I am on the rest frame of train. That means I am sitting on the origin of one coordinate system that will attach to train. So you have n number of coordinate system, and every coordinate system have attached to some frame. You can visualize something like this. So there is a coordinate axis, and this coordinate axis attached to some frame. So you have feeling of frame, but when we are doing mathematics, that time we have to just see there is one coordinate axis attached to that frame, means there must be some direction given by x-axis, y-axis, z-axis. And in general, we are taking this notation for x-axis, y-axis, z-axis with respect to origin. So origin is a point which is defined null, nothing, 0, 0. So you have to just define this point as 0. So if you have one coordinate axis attached to frame A, there is one origin attached to there, and suppose this is attached to some train. Suppose this is attached to, let's say, some any train, and we can just give notation of this particular frame. Suppose this train is moving with respect to another train, then there is one another coordinate axis, and it has its own origin, and it has its own axis, x, y, and z axis, and that should be common for the simplification purpose, such that this x-axis will just parallel to this x-axis, such that we can solve problem very easily. So you can have different coordinate system attached to different type of frame. This is very simple thing. This is very trivial thing, nothing to explain more. But when we are talking about coordinate system or frame, we should signify where is my origin and how this x-axis, y-axis, and z-axis are defined. So this is first definition we have to learn. Second thing, how do you visualize motion? How do you visualize motion? Can you please tell me how do you visualize motion? Anybody?
With respect to our frame,
Can you visualize motion independently? with respect to only one frame?
No, sir.
Never, never. Whenever you are talking about motion, you have to at least talk about two different frames. Suppose I am just going to tell you that the train is moving with speed 100 kilometer per hour. Is that this statement is correct?
No, sir.
No, this statement is not correct. You have to tell with which frame or with which observer the train is moving, and what should be speed depends on where is observer and what is relationship between observer and your particular train. So whenever you are talking about motion, you should always talk about minimum two frame. Minimum two frame. Obviously, you can talk about three frame also, four frame also, but minimum you need to define two frame such that you can say about which frame, which one is moving or which one is and how they are moving. Now, can you please tell me that motion is absolute or relative? Can you please tell me whether motion is absolute or relative? Anyone? Can we say that any motion which will be absolute motion? No, you cannot say. Motion are always relative, always relative. So I am saying there will be minimum two frame. There will be minimum two frame such that you can define the motion. For example, if I am talking about, let's say there is a frame A and there is a frame B. And let's say this is my frame B. Obviously, there is one axis attached to frame A. There is another axis which is attached to frame B. And if I am saying frame B is moving with respect to frame A, what is meaning of that? Meaning of that, if observer is sitting on frame A, then he will see that frame B is moving. But if observer will attach to frame B, what he will see? Is that B is moving? No, B will not move. What he will see? He will see that A is moving exactly in the opposite direction of B. So obviously there is never be absolute frame. You have to talk always relatively. What will be, where is observer and what will be his observation? This is all about relative frame. Now, just tell me, what is meaning of rest frame? What is meaning of rest frame? What is meaning of rest frame? Anyone?
So if the for the with respect to observer, if observer and the attached motion is in the same frame, then we can say with respect to observer.
Means if there is not any relative speed between observer and frame,
Yes, yes.
if there is not any relative speed between observer and frame, then you can say the frame is rest with respect to observer. So rest frame means there is not any relative motion. There is not any relative motion. Then you are just talk about rest frame. Means if I am saying a person is in rest frame of train, means the person is sitting on a train and he is not moving with respect to train. This is very important for solving the problems. What is rest frame with respect to observer. Every frame is not rest frame unless until you will not see what will be the relative motion between the observer and the frame is going to 0. You cannot say this is your rest frame. When there is relative motion between observer and frame, then you will say this is said to be moving frame. So all these things are very trivial, because you have feeling of all particular thing. But let me ask you one a very genuine question. What is meaning of inertial frame? Inertial frame. What is meaning of inertial frame? Can anybody ask me? Anybody tell me the answer?
Non-accelerating and
Non-accelerating.
non-deaccelerating.
Sorry, क्या है?
Non-accelerating and non-deaccelerating.
Inertial frame, very simple definition. What is
Sir, they
inertial
obey
frame?
Newton's law. Observer is attached
A0, B constant.
non-accelerating. Sir, they obey Newton's law.
Sorry, you are not audible. क्या बोल रहे हो?
Velocity constant.
Sir, which frames
Obviously, if I am
obey
talking about
Newton's
motion, we have to talk about two frame. So we have two frame. So when we can say this is relative, this is inertial frame.
observer is
No pseudo
attached
forces.
to accelerated frame.
Okay.
It's called
If we are talking about inertial frame, if we are talking about inertial frame, which means non-accelerated frame. Non-accelerated frame. Now, what is meaning of that? Meaning of that, the frame must be moving with respect to another frame. The another frame may be moved with respect to another frame. There may be a story, but at least we have to define two frames such that we can discuss the motion. So suppose I have one frame, and let's say this frame is S frame, and it is just according to definition, this is inertial frame, means this is moving with respect to some another frame with constant velocity. And this velocity must be constant velocity. And let's say this frame is some sigma, and this is moving with respect to sigma with constant velocity. Now, can I claim that motion of S frame will be always in a straight line? This is very important. The motion of S frame with respect to sigma will be always in a straight line. Can I claim this?
no, sir.
No. सोचो इसके बाद जवाब दो. This is very important. What I am saying, if S frame is inertial with respect to sigma, that means this S frame is moving in a straight line. That's it. It will not going to change its direction. What will be the initial direction of motion? It will just continue to follow that direction.
Sir,
Is that this statement is correct or false?
sir, I can't understand.
What I am saying this is one frame and it is inertial frame, which means this frame is moving with respect to sigma, because I have to define the motion. But if it is inertial frame, it will just move in a one particular direction. Is that statement is correct or false?
Correct, sir.
True, sir, because no external force is there, so maybe.
Velocity constant, so straight.
Anybody else?
So it must require force to change the direction. So it is a
Exactly.
non-accelerated frame.
This
So
is
yeah,
non-accelerated frame, means it has constant velocity. If it will change its velocity either in direction or magnitude, you need to give some force to this one. And this is definition of inertial frame, which is actually non-accelerated. So on this particular frame, there must be not any external force. There must be not any external force. If there is not any external force, then what will happen? Whatever be the its initial condition of a motion, that will we always continue. That will always continue. So whenever we are talking about inertial frame, that means motion is in one direction. The motion is in one direction. You cannot change the direction, neither you can change this magnitude. Because if you are going to change the direction, then you have to give some force. So this is very important, that for the inertial frame, the motion should be always continued just in a one particular direction. Are you people going to understand this thing?
yes, sir.
Okay. So this thing you have to always keep in mind. Okay. Now, last definition, that is very basic definition, class 10 definition. Okay. What will be t is equal to 0? What is meaning of t is equal to 0?
Motion started.
At some t is equal to 0?
Yeah.
What is meaning of t is equal to 0? Can anybody tell me answer? What is meaning of t is equal to 0? This is very important, because unless until you
Initialization
will
of
not
any
define this thing,
process.
then obviously next level will be little bit tougher. What is meaning of t is equal to 0?
So initialization of any process or motion.
Obviously that is t is equal to 0. But in form of motion, in form of two frame, what is t is equal to 0? Any girls can give
Origin
the
is
answer? Ayushi, Dhurvi, you can give answer. Only one people is only giving answer.
The time at which we started observing.
Okay, the time when you started observing. Okay, ठीक है. Good.
दोनों का origin coincide करेगा तो
Exactly. Good. Very good. What is meaning of t is equal to 0? So this S frame is continuously moving with respect to this. It is continuously moving. What is meaning of t is equal to 0? These two frame, obviously in relation to each other. If this frame is inertial with respect to this, then this frame is also inertial with respect to this, because we are talking about relative speed, relative motion. So t is equal to 0 means when the origin of both the frame coincide, then this time is set to be t is equal to 0. That means this situation, S and sigma, this will be all about t is equal to 0. Are you getting this definition very clear? Okay. So this status, when origin of one frame and the another frame is going to coincide, then we can say this is just as an initial time, and which is defined as t is equal to 0. So this is very basic knowledge, class 8, 9 class knowledge. So I think you should revise this thing very properly. Two things is very important. Let us summarize this thing. The first thing is that the motion is always relative. There is nothing called absolute frame. And inertial frame means non-accelerated frame, which means the frame will be just follow one direction and one magnitude of velocity. This thing is very important. So let's go for a Galilean transformation. यहां तक कुछ पूछना है? Anybody? This is very simple. I know. ये बहुत ही आसान है. So obviously there may be not any query. Okay. So let's go for a very important transformation, which is known as Galilean transformation.